The Mandelbrot set is one of the most recognizable images from mathematics. It is a fractal, a shape that is as complex at a large scale as it is at a small scale. Zooming into the image reveals patterns that have been likened to seahorses, scorpion tails, and snowflakes. Similar shapes appear and reappear. The mathematician who came up with the term fractal and made this set famous was Benoit Mandelbrot. He worked as a researcher for IBM, whose powerful computers would give his equations visual life. Nina Samuel, an art historian, gained access to Mandelbrot's collection of working papers shortly after his death in 2010. With those papers, she curated a show that reveals how images can inform discoveries in mathematics. Mandelbrot and his research team were originally seeking to understand complex polynomials through visualization. Some experimental runs through the computers produced shadowy figures, some of which resemble shapes from the yet undiscovered Mandelbrot set. Each image provided patterns for Mandelbrot to pursue and decipher, ultimately informing him how to adjust the data input. The Mandelbrot set is a mathematical set of points in a complex shape. It is related to other complex shapes called Julia sets, superimposed here in red. The limited power of computers at the time stymied Mandelbrot's efforts to calculate the finer details of the set. Here, we see instructions to investigate speckles surrounding the set, something he referred to as islands. While Mandelbrot thought in rich visuals, this is one of the very few drawings in his hand, detailing his quest to determine if the islands were actually connected to the larger set. Ultimately, mathematicians Adrian Dwadi and John H. Hubbard would prove that the term island was a misnomer and the dots were in fact part of the whole. Mandelbrot also investigated other fractals and was interested in chaos theory, the idea that small initial differences between two dynamic systems could result in drastic differences over time. This image shows an attempt to visualize the dimensionality of such chaotic systems. The complexity and apparent randomness of fractals can be used to create artificial landscapes, such as this mountain, that mimic the natural world. Visual representation of math can be more than just beautiful or illustrative. Here is a chaotic system known as the Lorentz attractor. It was first published by Edward Lorenz, a mathematician, meteorologist, and pioneer of chaos theory. Nina Samuel describes the system as existing between two geometric dimensions, but the flat image does little justice to this idea. This image is the same attractor drawn in Lorenz's hand. With pencil on paper, the scientist explores the shape and its characteristics. In this way, theory emerges through the process of drawing, according to Samuel's research. Now, with advances in computing power and technology, the chaotic system's shape can be more clearly visualized. In these pages, German biochemist Otto Rosslier uses a highly visual thinking process to discover a new chaotic attractor, even before he knows the equation for the shape. On the first page, Rosslier starts with one of Lorenz's systems. The dual spirals of the attractor are in the lower left. By drawing and redrawing, Rosslier changes the shape. Here, he writes soft watches in German, drawing inspiration from a famous painting by Salvador Dali. Rosslier also visualized the system jumping between two sheets of paper. Eventually, he identifies the final form of his new attractor. Later, he marks the discovery with a green arrow. Rosslier told Nina Samuel that he knew the system at this point, and all he needed to do was to prove the equations mathematically. A simple task with the shape already clear in his mind.